Hi students, in this video we're going to look at binomial distributions. Right, so after watching this video you should be able to identify contexts that are suitable for binomial random variables and also understand the formula for how to calculate probabilities and the importance of all those letters there. Now, big things to recall. So remember back to our lesson on Bernoulli trials. It's only one event with two possible outcomes, success or fail, where P is the probability of success. Now, a binomial distribution results when a Bernoulli trial is repeated multiple times. Okay, so you have some event that only has two outcomes repeated multiple times. Now, the key thing to note about this is for a binomial distribution, all trials need to be independent. So that means one event can't affect the probability or the outcome of the next event. Okay, that's the first thing. Second thing, there still need to be only two possible outcomes. It's a Bernoulli trial, repeated over and over again, so each trial should only have two possible outcomes, and the probability of success must stay the same. Okay. If you're doing any sort of question about evaluating reasonableness, a good thing to evaluate when it comes to reasonableness is, well, is the probability of success actually staying the same, or are we just assuming it's staying the same so that we can use binomial distributions? Because often we will just assume the probability is the same solely for the purpose that we can use binomial distributions and all the formulas that come with it. All right. Here is the formula that was used once upon a time to calculate the probability of R successes out of n trials. So the key things with the variables, R always represents the number of successes. Okay, R represents the number of successes. N always represents the number of trials. And P always represents the probability of success in any one event. Okay, when we get to solving problems in our next video using our graphics calculators, those values are incredibly important. So we need to know what they are. How many successes are we looking for? How many trials are we looking for? What's the probability of success in only one event? Now, what your calculators will be doing when you solve these problems is applying this formula. So P to the R, right, that's just the probability of getting R successes. So if your probability of success is 0.5 and you're looking for 5 successes, that'll be 0.5. I might make it 0.6 just to make it interesting. 0.6 is my probability of success to the power 5. Now, let's say that I'm actually getting, let's say I'm doing actually 8 trials. If I'm doing 8 trials and I want to find the probability of getting 5 successes, and my probability of success is 0.6, well, I'll start off with 0.6 to the 5. There's my probability of getting 5 successes out of 8. But the thing is, if I have 5 successes, what about those other 3 trials? Right? I'm doing 8 trials in total, 5 of them are successes, so the other 3 must be fails. So my probability of not succeeding is going to be 0.4, because if success is 60%, 0.6, the remaining 0.4% must be fails. Now, if I've got 8 events and 5 are successes, that means the leftover 3 will be my power there for my number of fails. Now, this number out the front here, 3, is a combinations number. It's the number of ways I can get 5 successes out of 8 trials. So if I was to try and list them, I could get win, 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 loss, loss, loss. That's one way of getting 5 successes out of 8 trials. I could also get win, 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 loss, win, win, loss, loss. And I could keep listing them out and work out what that number is. Now, for the most part, your calculator should be working out those numbers for you. But hypothetically, if in an exam, whether internal or external, if you have to work out these numbers, remember, well, back in Unit 1, we used Pascal's triangle to help us work out number of combinations. In that situation, it was in the context of binomial expansion. But we can also use it here in a non-calculated situation too. So let's do another row actually, just to get some variation. 1, 5, 10, 10, 5, 1. So this number here, this 6, represents the number of ways of getting, well, there are 4 trials, and that number 6 is the number of ways of getting 2 successes out of 4 trials. The key thing to remember is that first element is going to be the number of ways you can get 0 successes out of 4, and there's only one. It'll be loss, 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 loss. This one on the end is the number of ways of getting 4 successes out of 4 trials. Win, 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 win. Right, so there's only one way of doing those. And then the numbers in the middle are that first 4 will be 4, 1. The next one is the number of ways of getting 2 successes out of 4. The next number is the number of ways of getting 3 successes out of 4. And so that number you'll multiply by the rest and then get your answer. Now, to be fair, most of the time you would be expecting that this is on a calculator exam because we're talking about powers of decimals and powers of fractions, which can get pretty gross and hard to do in a calculator paper. But in case you need it, Pascal's triangle is where that NR combination number here does come from. Now, when we're referring to a binomial distribution, this is a common way of referring to it, x tilde BINP. So that's the binomial distribution that has n trials and a probability of success p. Just a way of using it there. And from there, you might say, all right, for this binomial, the question might be for the binomial distribution BI 10 0.6. Right? We want to find what is the probability of x being equal to 9. So that might be one way of looking at this. You might see a problem where it gives you the n value and the r and the p value straight away. The r value here, the number of successes, is 9, and so you can then work out a probability from there. In the next video, we're going to talk about how to use your graphics calculator to solve these sorts of problems. But the key thing I want you to get from this slide here, know that that's the formula, where it comes from. In case of emergency, know where the ends, those combination numbers at the front come from. But most importantly, I want you to walk away knowing that the important numbers we need are n for our number of trials, r for our number of successes, and p for our probability of success in just one trial. All right, let's try and do this in the situations we've got here. We want to find n, p, and r in these problems. So in the first one, getting 6 tails out of 8 tosses of a coin. All right, so if we're tossing the coin 8 times, that's our number of trials. Okay, we're doing the experiment 8 times. The number of successes we're looking for is 6. And, well, what's our probability p? Well, we're assuming we've got a fair coin. So we're assuming the probability of getting 1 tail in 1 toss of a coin is 0.5. Right, in the next one, we've got Aaron. What's the probability of Aaron getting 5 or more questions right out of 10 on his multiple choice quiz, where each question has 4 options? All right, so he's got 10 questions, so that's his number of trials. Now, we've got 5 or more questions right, so our R value isn't equal to 5. We're looking for any R value that's equal to or greater than 5 or more. So R is equal to or greater than 5. Now, each question has 4 options. Now, we can assume that only one of those options is right. So the probability of successfully getting 1 question right is picking one of the 4 answers that's right, or 0.25. For the last question, a basketball team winning 4 or more games out of 7, if they're probably winning a game is 60%. This is like the second one. We've got 7 games that we're playing. We need 4 or more successes and the probability of success is 60%. So a pretty straightforward one there too. Alright, so students, after watching this video, you should be able to understand the concept of binomial distributions, identify contexts that are suitable for binomial distributions, and then understand the formula and what those parts come from, but in particular, know the importance and significance of our variables: N for number of trials, P for probability of success in one of those trials, and R for the number of successes we're looking for.